Good afternoon, everyone. Thanks for joining Scale Computing's webinar today, hosted by Ingram Micro's Emerging Business Group. My name is Carlene Edge, Marketing Manager here at EBG. Today's webinar will last approximately 45 minutes, and in terms of general housekeeping, your lines have been muted for the duration of the webinar. If you have any questions, please feel free to type them in the Q&A box on your screen, and we will address them at the end of the presentation. Today's webinar will be presented by Dave Demlow, VP of Product Strategy, and Scott Mann, Director of North American Channel Sales. So Scott, if you want to go ahead, the floor is yours.
Thanks so much, Charlene, and welcome all. Appreciate everybody taking some time into their day today to meet with us. I'm not going to be going over a chunk of the presentation here. It's going to be Dave Demlow. I just wanted to preface the presentation a little bit before we get into it. So there's been a lot of talk around our video surveillance solution, and there's been a lot of interest from all our partners out there. Many of you that I see on the call already have asked a lot of questions about this video surveillance solution. I feel like we fit a portion of the gap, or a gap within the market that a lot of other products out there that you might be familiar with today don't address. And this is, I think, bringing video surveillance to maybe expanding out on any of your product offerings that you currently have, and going a little bit beyond and extending out that data center sale and talking about video surveillance. So even if you're not selling it today, I think this is a great opportunity for you to listen in and see how easy it can be to extend that sale and talk to your customers about a video surveillance solution on HC3. But for today's presentation, I'm going to actually pass it over to Dave Demlow, who's our VP of Product Strategy. He's been integral piece to putting together the video surveillance solution for us. So no one better to pass this over to than to Dave. So without further ado, Dave, over to you.
Awesome. Thanks, Scott, and thanks everyone for joining today. So yeah, I'll give kind of an overview of the video surveillance market, how it fits into IT, specifically why in many opportunities it's going to make sense to put it on hyperconverged infrastructure so you can combine the storage, the compute, get operational simplicity, simplify and centralize management, reduce the overall cost, and not end up with different islands of infrastructure. With these dedicated purpose-built video appliances that sit there and aren't easily expanded or aren't easily managed like the rest of the IT space. So so some of the trends. We are seeing various companies in different stages of moving video surveillance and security from kind of isolated functions within larger organizations and islands of infrastructure to integrating it into IT practices, IT management, and into the mainstream IT group. Some of the reasons that this happens are, many years ago, not that many years ago, these were analog systems, CCTV, analog cameras, purpose-built with proprietary camera formats, proprietary recorders, things like that. Nowadays, everything that's being deployed today is based on standard IT-based technologies, IP-based cameras, digital recording, storing on, in standard formats, like the media streaming and so on and so forth. So the benefits and the needs for having proprietary purpose-built recording appliances has gone away. It can be easily streamed to general purpose computing infrastructure, standalone PCs, hyperconverged clusters, virtual machines like we're going to talk about. And that's really transformed the ability to manage these with the same best practices and with the same team and resources that traditional IT applications benefit from. And in many cases, it's going to be suitable to actually run the video and the security applications right alongside other business applications on hyperconverged infrastructure. There's some cases where you may not want to do that, very large scale systems, which we'll cover. But there's always been a management challenge in the video space. So, even as there was this transition to IT, you'd have the old security teams try to pick up the new technology and have to deal with issues like building server infrastructure, installing operating systems, setting up IP networking, all the things that, traditional IT organizations and IT service providers are well familiar with and trained in, dealing with other issues like how do you make these critical systems highly available, scalable, things like that. And as in any business or any line, affordability and value is always top of mind. So why would you virtualize video security? And this is a document from Milestone, who's one of the top VMS, if you hear the term in the presentation, VMS is not VMs here. It's probably video management systems or video management software. Those are, the collective set of pieces that receive the video streams, record it, index it, analyze it, add metadata to it, provide streaming services. And so Milestone is one of the major players and one that we've partnered with along with many, many others. But they specifically recommend, if you're designing a large scale VMS system, they recommend that you base it based on virtualization technology because of the benefits that you get of making it easy to clone and deploy new servers and applications, portable server images that you can move around. They're not tied to a specific piece of hardware. High availability support, often just built in and for free. Seamless migration, live migration, so the ability to do physical server maintenance, add capacity, replace components without impacting ongoing recording or availability, and then the ability to kind of resize the video applications as necessary. Give it more CPU, more virtual machines, or as we'll talk about a little bit, by basing it on Hyperconverged, you also get the benefit, particularly with Scale, of adding new nodes with new capabilities down the line, adding all flash nodes if your IO or latency needs change, or adding GPU-based nodes if you want to in the future be able to do in-place analytics on that data. So virtualizing VMS software and security and all the pieces that go around with it. I'll talk generally about VMS, but there's a bunch of other security related pieces that generally are tied into and integrate everything from access control, door lock systems, to some analytic kinds of applications, people counting, things like that, and those all tend to tie together and get lumped in here. So for many of you who are familiar with Scale, this will be kind of an overview, but the old way of doing virtualization, and certainly the security focused legacy team is not going to go and become VMware experts and SAN storage experts and set up an elaborate 3-2-1 architecture just to run their VMS system. So moving them right to a hyperconverged infrastructure where they get, out of the box clustering, web-based management, non-disruptive system upgrades, self-healing architecture. They don't have to be on top of, constantly, hey, if a hard drive fails, am I going to continue recording and having access to video? Integrated backup, rapid deployment, seamless scale out, which is a really big thing when you think about video surveillance and increasing numbers of camera counts, increasing resolution of content, and then increasing retention. A lot of industries, for whether it's for regulation purposes or whether it's just, hey, we now see value we see video and security and surveillance and analytics as more than just a must do of, hey, let's see what happened last night or last weekend. Starting to retain that data for a longer period of time. And getting value out of retaining data, large amounts of data for a long period of time. So scale out and different ways of handling storage, like we'll talk about, become important. Hyperconverged, for those who may not be familiar, is really just combining what used to be separate products from separate companies. Going out and buying servers from one company, storage, whether it's integrated or SAN or NAS from another company, layering in a third-party hypervisor, cobbling it all together yourself, and checking hardware compatibility lists, getting rid of all that, putting it into a single system that's a fully integrated architecture with inherent resiliency, high availability, and so forth. That's what we mean by hyperconverged. In the video management system context, to really make this clear, what some of your customers may be dealing with in terms of alternatives, this is also, the diagram on the left is also out of that same Milestone document, and this is one of their recommended architectures here for setting up a fully resilient VMS system. And there's a few things you can kind of see from here is, one, a VMS system on a larger scale may have multiple components. It always has these components, whether you split them out into multiple servers or not may be required. But, on the bottom are what we all think of, the recording servers that sit there receiving data streams from the cameras, writing them out to persistent storage, maybe doing archiving. Those are kind of the critical things that we all think of with video surveillance. And in the case of providing resiliency for those, most VMS systems have some level of built-in failover, so what you can see here is, I might have resilient recording servers where there's primary recorders and then there's secondary recorders that sit there, do use a license, do run, Windows, do use a piece of hardware that basically sit there waiting to see if their primary server has failed. And if so, the camera streams switch over to them. They continue recording the new data. An important thing in some instances, though, is to point out that that doesn't provide resiliency for the previously recorded data. It's just a standby recorder that'll resume recording new feeds. But if this is an industry where I need to, at any time, be able to go out and say, hey, what just happened 5 minutes ago? This is a retail that's very critical, or in a casino, obviously, things like that. These types of high availability don't provide continuity for existing recorders. They just continue recording new streams. Whereas building this on HC3, you just automatically get continuity for the recorder. You don't even have to set up a standby. It's just any workload, any virtual machine and all of its data is inherently highly available, will fail over from a full node failure even and resume on other nodes of the cluster, easily handle other things like disk or network failures. Then across the top, you get into some of these other pieces that are part of a VMS system. The management server is kind of the key one. You can think of that as the brain that keeps track of all the pieces. These are all the cameras that I have. These are all the recorder systems that I have. These are all the other peripheral things. And that's a very critical piece to keep available if you want to be able to access video and look at indexes and things like that. So in their document, they're actually recommending that you build a hardware physical Windows Server failover cluster with again an active standby kind of configuration, and then potentially for other pieces there's a component called the event server that handles a lot of the metadata and alerting and things like that. Could be another Windows Server cluster. So that would be a very complex way and a very inefficient way to provide for redundancy and failover for a VMS system. And over on the end there, you've got a SQL server that you probably also want high availability for. Whereas putting it on Hyperconverged, you get automatic resiliency. Everything you do, everything you create, whether it's a recorder, whether it's any of these other roles or other applications, is inherently highly available. Kind of across the top, if you're not familiar with HC3, this is showing a picture of a 4-node system. Each of those, the little white boxes, are virtual machines running on those systems. So I think this particular one, when we took the screenshot, had 8 video recorder servers running in virtual machines. If any one of those nodes failed, there was more than sufficient compute resources available, RAM, for the recorders running on that nodes to fail over and resume operation on one of the other nodes automatically and so forth. And also proactively, like if there was a new Scale had a new upgrade for HC3, we can apply that to one of these clusters without taking any virtual machines down in a non-disruptive rolling upgrade, which is another key thing of keeping continuity. And then along the bottom, this is just kind of the storage view showing in this particular case this cluster. Again, 4 nodes. Each one of these nodes has its own local storage that's managed by HC3. These were, I think, 18 terabyte drives in each particular node. So this was a high-end configuration, about a petabyte of total storage. Most video recorders are nowhere close to that. I think this was 800 cameras, 4 megapixel or 4 megabit streams, fairly high resolution and long retention that was designed for here. But the key is it's all easy. It's just, HC3 is that, autonomous self-healing infrastructure, and then deploying, virtual machines is very easy and inherently secure. So again, why, to summarize, why hyperconverged infrastructure for video surveillance? It's a simplified single pane management, and I will, we should have some time, I'll at least give everyone a quick run through of the HC3 user interface. Very rapid deployment of the HC3 system, both initially and when you need to add capacity. And you need to add additional storage resources, additional compute resources. Intelligent automation of many tasks, things like disk drive replacement are simplified. You don't have to, it's not like a RAID system where you have to go in and do a bunch of things manually. High availability keeps the systems running, absorbs hardware failures, and keeps the applications running. Lets you buy what you need when you need it and scale easily. And that's trying to anticipate what capacity and performance needs, and in many years out is very difficult. And so the ability to buy what you need today, knowing you can add and expand later. And a unique thing about Scale, if you're not familiar, is that we do allow you to mix and match different nodes. So you're not, with the node you buy today, you don't have to buy the same thing in a couple of years or in a year. You can buy the latest, greatest, deepest, fastest, cheapest, and mix and match. There's, always logical rules and best practices there, but we do design wherever possible to allow new generations, higher capacity, higher performance systems to be intermingled with that. No expert certifications to manage, and then no complex, expensive third-party virtualization licensing. Everything that you need to begin deploying your VMS system is built in. The hypervisor, the storage, the compute, and so forth. What do customers value most? Again, simplicity, the unified management, everything's pre-configured, fast to deploy, all the high availability pieces. It's just designed to be autonomous and automatic. A disk drive fails, it's going to take care of that for you. Make sure the systems, continue to run, data is available, you're fully redundant and resilient, and then at some point you replace the hard drive, under warranty, but it's not a fire drill to go do that. Integrated backup, replication, disaster recovery built in, scalability from a single node, and I'll actually in the demo show a single node deployment on many smaller environments, what we call edge type, computing systems where, there's maybe no IT and they just need kind of limited on-prem resources. You can start with a single node. You can scale out, from there, cluster, and I mentioned the mix and match, and then everything built in, complete stack with software support, with services, all in at much lower prices. So HC3 infrastructure for video surveillance. I talked through this a little bit more. Kind of the red circle at the top, would represent, in that case, a 3-node HC3 cluster running virtual machines. You've got, the cameras there streaming their data over the network, into the virtual machines, running whatever VMS software, and we'll talk about some of the different options there. Users, security people monitoring, monitoring the video streams and events and so on and so forth there. A key point here is that you get the high availability, but you also kind of inherently you're able to design a more powerful system using a collection or a cluster of less expensive systems, which is infinitely more efficient when it comes to than trying to buy the biggest, baddest, fastest, beefiest server you can buy, put all the redundancy you can, into that, and then cross your fingers that you don't have a CPU failure or motherboard failure or things like that. And video surveillance, unlike a lot of applications, is one of those that is naturally just super easy to load balance. So, as I described before, and you can see here, rather than having, even 4 big video recorders, it actually made a lot of sense in this deployment to split it up into smaller chunks that can be moved around. So say, for example, we add a new node because we already have 8 recorders, maybe we add a new node and we add, move one of the recorders over, add a new one. Depending, we have a lot more flexibility to distribute the load across multiple recorders, multiple physical servers, use lower cost servers, and get a collection and achieve high availability through that clustering capability, yet keeping it very, very simple to manage. So in terms of other server workloads, again, we're focusing on video surveillance, but HC3 runs them all. I mean, virtual machines, containers, Kubernetes, anything that runs on x86 hardware and can be virtualized, which is almost everything, will run on HC3. And our systems engineering team can help you design, the right system, whether it makes sense to combine, database analytics, your ERP, file server storage, video backup, how much of this to run on a single cluster versus having a couple of clusters, maybe with different pools of resources. But that's also really kind of a key thing in the video surveillance because, they have to tie into Active Directory. There has to be an Active Directory server there for security. If they're providing external streaming access, which is very common, there's going to be a firewall and some sort of, external proxy server to get access to that. In many cases, they're going to use VDI type technologies or remote desktop technologies to provide monitoring, to actually, virtualize the desktops that are doing the security monitoring rather than having physical boxes that have to be patched and maintained and so forth. So, another benefit of virtualization is that you can put everything. You can have your whole site, whether you're a retail store or manufacturing facility, in a box, and run all your critical applications there with that same high availability and ease of use. So let me switch over and just kind of give a quick demo for those who haven't seen the HC3 system live. And again, we do weekly demos. We can go very in depth. Just kind of some things to show here. Let's just filter on running systems. This cluster is actually pretty busy. It's doing some other stuff at this point other than video, although there is some milestone video actually running here. Let's just go, how easy it is to create a new virtual machine. So, this is a 4-node HC3 system. I point a web browser to any one of the nodes in the cluster. It doesn't have to be any specific node. There's no separate management server that I need to install or maintain or patch. Log in with, credentials, or you can integrate with Active Directory. And let's just create a VM. We'll call it test. We want to go ahead and install Windows. Let's go ahead and give this one, 16 virtual cores. We'll give it 16 gig of RAM. We want our boot drive to be 300 gig. We're going to do some video, so let's give it a couple of 8 terabyte virtual disks on here, and we'll boot from a Windows Server ISO and install Windows. So with just that quick configuration, we'll go ahead and click create. Let me filter on that. Just takes a couple seconds to create the metadata there. And then we'll go ahead and spin it up, and it's that easy to create a new virtual machine and power it on. And in this case, we would begin installing Windows into this virtual machine. Everything you need, again, we've talked a lot about high availability, but sometimes there's proactive maintenance you want to do. Let's pick a small VM here. This Red Hat Core OS test. I can live migrate it. Right now it's running on this node here. If I click this migrate button here, let's say for resource balancing, I want to move it over to that node. I can do that without any shutdown, without any disruption, so on and so forth. So we do actually have Milestone running here. My Milestone system here, you can see this is actually doing some real work. It's running some CPU, ingesting some data. We'll go ahead and look at the console running here. It's a Windows server, and this has got all the Milestone stuff to record. We'll just look at the status message, but nothing too exciting. It's sitting there receiving data. Actually, I think I probably have a task manager here. Receiving data, storing it out to disk, and all being managed by a remote management server there. So you have everything you need to to manage. And then for resources outside of that, things like integrated snapshots, replication. If I wanted to set up a replication schedule, I can do that here. Let's see, we'll pick replication default, and actually that's a snapshot schedule. Replication, I would pick from a target cluster. In this case, I already have one target cluster that I could replicate to. This is a pretty large VM, and I don't want to replicate it, so I'm not going to go ahead and do the button there. But all those kinds of capabilities are built in, super easy to manage and utilize. Another thing I want to show is really on the small end. So we've got a server here, and this is a single node system, as I mentioned earlier. So there's only one node in this particular system here. It's running a bunch of different workloads, like maybe you would see in a small store. Again, because this is a one node system, there's no automatic high availability here. So I would definitely want to leverage replication to another system and so on and so forth here. But this is actually running a small Milestone system here. And we actually are listed on the Milestone marketplace, have validated. This is based on our HE150 small form factor system. These are the little 4-inch by 4-inch cubes. We actually validated a 3-node cluster of these running Milestone VMS with 25 cameras, which would be more than adequate for a smaller retail organization or a lot of locations, alongside other we were kind of simulating a retail store in that case, or alongside other applications that you would find in a retail store. But this is again a single node system. The management is all the same. Let me just actually show you a 3-node configuration. Again, with this is the small form factor system doing some other applications here. These are a little bit bigger. These ones have 64 gig of RAM, but then again, these are still the small form factor systems. And one of the things I do want to point out is we do have a wide variety of nodes. I talked about mix and match and the ability to add nodes of different types. You can also add nodes with different resources. So, a common question, particularly relating to video with VMS is, well, what if I need a lot more storage? I've increased my retention requirements. I need a lot more storage. I don't necessarily need compute. I just need to keep data longer. There's a few ways to handle that, particularly with video. You can archive to external storage or things like that. But Scale does have the ability we have very storage heavy nodes, and you can buy nodes that are storage heavy, just minimal compute, and turn them into what we call storage only mode, which is something that support sets up. And so this node here on the right that doesn't show any of the white virtual machines running, that's a node that was set in that particular case. So this is almost where we kind of call this a 2.5 node cluster here. I've got 2 compute nodes. I've got 3 nodes that are actually contributing to storage and maintaining cluster quorum, so that you don't have accidental failovers and things like that. But this is the cheapest node that we make on the right there, and it's just contributing storage and doesn't need the same amount of RAM or same computer, things like that. So there's a lot of different design options that we can help you with when it comes to sizing and so forth. So let me switch back to here. All right, so talking about VMS software on HC3. All VMS software out there is, generally Windows or Linux. I've started to see there's some coming out in container form, things like that, but generally they're Windows apps, Linux applications that, we run Windows and Linux and containers all day long. So you can install, those running inside HC3 virtual machines. Some of the popular ones that we've tested or are validated with or have customers running. I've mentioned Milestone XProtect many times. Genetec is another major player that we've worked with. Axis, Digital Watchdog, Blue Iris, Pelco. There's a super long laundry list of VMS providers out there. These are a lot of the top ones. Mirasys, I guess, is one that we actually partner with as well. The general rule, if it runs on Windows or runs on Linux, Windows and Linux run great on HC3, and it'll probably run there. The only exceptions would be is if they have any specific direct hardware physical integration, as opposed to using IP network cameras. But most everyone at this point is more or less camera agnostic. There's an open standard called ONVIF, ONVIF, that they all support for IP-based cameras. Some have their own proprietary cameras, and that's fine as long as they're IP-based and just connect into the recording server using IP. So Scale is Milestone verified and listed in the Milestone market with several different configurations. They just happen to be one that has a very good ecosystem and a process for submitting tested, validated configurations to a specific simulation size, how many cameras, how much retention, things like that. But running VMS on HC3 and Hyperconverged is very well suited, especially for distributed edge locations, retail, entertainment, hospitality, manufacturing. Can run all their critical on-premises applications on a single resilient platform. And then I would say also consider the benefits of running other physical security applications, your access control, and then just the basic infrastructure things that you need everywhere, like your Active Directory, your DNS, maybe virtual firewall appliances, things like that, to reduce the physical footprints, take out the number of physical pieces of hardware in these remote unmanaged locations and reduce the overall management overhead. So just some ideas on cluster sizing examples. Like I said, actually, sorry, it was 50 cameras. I think I mentioned 25, but what we did validate was actually 25 on a single node. It was in a cluster, but it was a node with an Intel i7 based CPU and those small form factor systems. So it was ingesting 200 megabits per second on that single node. That is listed in the Milestone Marketplace. That configuration is, it's just 6 cores, 12 threads, up to 64 gig of RAM, up to 4 terabytes of storage directly on the node, and then you can obviously cluster those together for more. But that configuration, that model, the HE150 model, and Scott's going to talk a little bit about a demo promotional offer that we have. That starts at under 15,000 MSRP for the 3-node highly available configuration on the base level. And then in the medium, these are some of the different scale models that you might see. Our HC5200 cluster will easily run 100 cameras, about 75 per node is what we recommend. So across a 3-node cluster, We got to about 900 megabits per second, and there's definitely plenty of network, plenty of storage IOPS there. And then even in the single node configuration, we did 50 cameras, and that has multiple drives, so it has local storage resiliency. On the large end, things get complicated, and here I think when you're getting into the 1,000 camera range, it probably does make sense just because of the different storage requirements, different kinds of CPU tuning that you can do to have a dedicated video storage cluster at that point. We have a variety of partners. We have some very large scale systems in large enough systems. There's even some custom type systems that are available, and we do partner there with companies that offer extensive experience integrating security surveillance systems for very critical environments like casinos and airports and so forth. But we can help put together the right software, hardware, and configuration for even those very large scale type of environments. Just some general solutions design, and again, work with your Scale sales team. VMS systems all have calculators that do sizing, and the good news about this is it's a fairly constant workload, and it's just math. I mean, if you have 100 cameras at 4 megabits, stream, you can calculate how much ingress bandwidth you need for that. So there's all sorts of calculators where number of cameras, what kind of bit rate, what % motion, if you're only recording motion events versus constant motion, how long do you want to retain the data, and they'll then spit out, this is how much storage, effective storage you need. In some cases, they'll guide you on number of kinds of CPUs and NICs. I would say in general, CPU cycles are the most critical in VMS, so don't skimp on CPU cores and cycles when it comes to that. And unlike a lot of other virtual machine environments or applications where they're not going to use that CPU again, these are going to sit there, doing this work, receiving the data, ingesting it constantly. So they're going to use the CPU that's calculated and allocated to them. We would definitely recommend, regardless of the rest of the network in the facility, if you're getting into a higher configuration, 10 gigabit networking is worth it, at least in the backbone and between the HC3 nodes. And you can do 10 gigabit there, but then have 1 gigabit out from the cameras and to your users and so forth. But if you're going to do this constant stream of data ingest from the cameras, writing it out to storage, and then if you're familiar with HC3, everything that's written, we're going to use that same network, the backplane connection to replicate redundant copies of data to the other nodes. So 10 gigabit ports are cheap, and especially with 10 gig base T, and well worth it, at least on the HC3 system. You can consider archiving data off primary systems to external SAN, NAS, or even cloud for long-term retention. I would say, for example, there are some regulated industries where they need to kind of keep everything almost forever, or keep it for 7 years, I've heard, in these cases. And in that case, designing your primary production HC3 video recorder system to keep all that probably doesn't make sense. And most of the VMS software does provide facilities to archive on a schedule. And it can even do things like, reduce the bandwidth or reduce the resolution and then archive it off to a remote system. I think I already mentioned, consider splitting recording servers across nodes for load balancing and other benefits. And then, another point, multiple clusters are also easy to manage. So at some point, if you're questioning, hey, do we, cram these, this many cameras into this 5 or 6 node system, it might be just as easy to have 2, 3 node systems and distribute them there and give you more room to grow down the line. And then just a point on kind of storage. There's all different kinds of storage we offer that's available, but with video storage, what you generally need is capacity, and you need kind of constant latency, because it's, again, going to sit there just receiving streams, writing them out to disk. You're not going to have peaks and valleys. So flash is not always required or even good necessarily for video workloads, and especially when you use a method that we call wide striping. So in the case of HC3, anything that a VM writes, regardless of what node it's on, is chunks of that data are distributed evenly across all the physical disk on all the nodes. So in that one cluster, I said there were 17 drives in each node. Every recorder can write some of its data and stripe it across all those. And when you aggregate all the IOPS that are available, even if you say it's 50 to 100 IOPS per disk, but you've got that many disks, it's a lot of capability. And the next thing then you consider is, well, what if one of those fails? What's a rebuild time? And again, that's where a large number of disks all working as a team can really do a lot of work. So we generally recommend still for larger video surveillance systems that you use one of our hybrid nodes that has both flash and spinning disk. And that's where you can actually use what we call our heat priority, which gives you a little slider on each virtual disk in a virtual machine that you can go in and say, well, I only want to use flash capacity for the operating system so that I can have fast reboots and patching and any kind of database that might live there. But on the secondary drive, I want to put that all on spinning disk and not waste the flash capacity of storing videos and so forth. So just some general solution designs there. A quick case study, and I think there's some video, and actually we did Jeff Miller and I, who's pictured here, did a webinar similar to this on video surveillance, where he told some of his story. But Jerry's Enterprises is a retail chain founded in 1947 with 50 locations, several different brands. Some of the things you might have heard of are Cub Foods. They operate some Cub Foods facility, but they're a retailer. They required, among other things, on-prem video surveillance systems that were easy to use, highly available. Each of their stores has 80 to 100 cameras, and they generally keep everything for 30 to 45 days to assist with fraud protection, lawsuits to come against them, things like that. They love their HC3 system. They've used a variety and are using a variety of VMS software. They use some Milestone, they use some Digital Watchdog, and kind of comparing them off. But they rely heavily on their video surveillance. Unfortunately, some of their stores were located in Minneapolis during the riots, and they actually needed to rely on and actually go in and physically retrieve their entire HC3 system that had all the store data and the video surveillance. It was being replicated, but they just wanted to retrieve all of it. And I think one of those systems is still in FBI custody, he had said. So there's more information online. Outside of that, Scale generally is, trusted by thousands of customers, everything from small SMB type organizations to very large distributed enterprises. And a lot of the, the kinds of locations where you'd see the need for this on-prem edge computing, manufacturing, hospitality, retail, quick serve restaurants, you see all those kinds of things represented up here. And video surveillance is pretty prominent across most of these segments. Certainly in the retail space, it's everywhere, and we're starting to see where it's not already been done more and more. The separate security team with their own gear, their own infrastructure, their own management, relying on IT to run all those critical applications together. We take great pride in our reviews, both from end users and channel partners, and it's a great selling tool for you. We can help out. I have hundreds of reviews on all of these sites, and have won awards as one of the top rated Hyperconverged vendors, across a number of these sites. But in your selling process, we can help you find customers that are just like your prospects, often down the street, and so reach out to us for help when it comes to support there. And then just a quick, summary here on our product line. I've covered, it's really our goal to have capacity, performance, and price systems, to run the full gamut. So everything from smaller edge deployments where form factor, physical size, half rack, you can see on the very left those little, the HE150 systems that I've mentioned a couple of times, to, tower-based systems where they're appropriate, to, full high-end GPU loaded, all NVMe nodes on the high end for core processing and analytics, and then also tying it into cloud for DR as a service and so forth. So with that, I'd like to get Scott back on.
Yeah, thanks, Dave. That was excellent. Always great to hear the video surveillance take from you. I just want to finish this off with really, what are next steps? There's a lot of great information that we learned here today. And I'm sure a lot of you are going to have to digest on that information and have conversations. This video will be available on demand after if you want to share it with any of peers, your colleagues, to get their take on it. And if you want to have a follow-up conversation, let's do that, where you can dive in deeper, talk about specific customer use cases. But for those that aren't a partner yet, what are the first steps to getting started? I've kind of summarized it here in 2 quick steps. First is obviously sign up as a partner. You can go to partners.scalecomputing.com. On the top left, you'll see that there's a become a partner, apply now. Click there, you just have to fill out your email address. And it's a quick contact info fill out. And there's literally a one-click sign up from a partner perspective. There's no minimum requirements, no sales quotas or anything to be a part of the partner community. So it is very seamless to become part of it. And then it's just figuring out, where do we fit together? Let's build out a strategy. Let's put a marketing plan in place and see where we can capitalize on some opportunities within the market together. And once you do get signed up, it's how do I get my team familiarized with this? How do I better understand what Dave was talking about here today? And the best way to do that is get your hands on one of the systems. Dave mentioned our HE150 system that you can see there. You can Google the HE150. We won Product of the Year with CRN with it. So it's a very highly sought after system that we have in place right now. And for our partners, what we want to do is we want to get your hands on it. So from a customer perspective, it's something that you can take to your customers. From an internal perspective, it's something you can use to enable your technical team and familiarize yourself with the capabilities, run video workloads, run VDI workloads, run regular infrastructure workloads on there as well. And to check out more on that, you can just put HE150 partner promo, Google that, Scale Computing, and that'll pop up on Google for you. But we can definitely get you more information on that, and the brochure and everything is in the partner portal. So once you sign up, you'll have access to that, and that'll get you access to a cluster to play around with, as well as our data center infrastructure certification, so that you understand what the installation, migration, and networking process looks like, so that you can go and make all your professional services dollars when you do install these at the first customer we run together. And with that, we will jump over, I think, the questions in the next slide. If you want to jump to that last slide, there's Dave. It does have our email on here as well, channel@scalecomputing.com. Any general questions, feel free to shoot those over to that alias.
Sure. And yeah, so anyone online, feel free to submit some questions, and we can come in here and answer them live. Let's see, we do have one here. I'll answer. Question is, for large-scale video surveillance deployments, what are the best options for high-capacity storage with HC3? So again, I talked a little bit about, depending on what your retention requirements are, we can easily go up to, a petabyte in a cluster. And if you need more, you can have multiple clusters. A lot does depend on what level of high availability, what level of access, what level of performance do you need for all those. Does it make sense to keep that all on HC3 for its entire lifetime, or leverage other storage? And again, access time, cost, reliability are all factors to consider there. On some of the edge systems, for example, after we did the initial validation of the 50 cameras on that small HE150 small form factor system, we did also another validation run where we kept the data there just locally stored on the system for about 14 days, and then after that actually set up a archival system where ultimately the data got up to Azure file storage and then was kept for several months up there. Using a combination of capabilities, in that case within the Milestone software, to do the archiving from the primary local hard disk storage that we provide through HC3 to a remote file share, which in that case actually happened to be a file server virtual machine that was running on HC3 that was backed by a technology called Azure File Sync from Microsoft Azure service, which basically takes what's on that Windows file share and moves it up to Azure Blob Storage, and then based on policies that you set there, like after it's been there a day or 7 days, or when there's capacity needs, it actually removes or stubs the file locally on the file storage. It still looks to users like it's there, to applications it still looks like it's there in the directory, but it's actually just a 0 byte placeholder. And if anything goes and touches that file for some reason, it just fetches it down from Azure. So it takes a little bit longer to read, remotely from the cloud, but kind of gives you infinite file storage capacity there, and can leverage some low cost cloud storage. And there's many similar systems that do the same or similar kinds of things. That do some kind of on-prem tiering or caching, essentially, backed by cloud storage for a longer term and lower cost storage. And all right, so that looks like the only question, unless, I don't know, Scott, do you see anything over on your side? Or
no, I think that's it, Dave. I think you covered everything.
Awesome.
All right, so we are all set. Thank you guys so much for presenting today, and everybody on the line. Thank you for being here with us. We will send out a follow-up email with the recording of the webinar. And if you have any other questions, please feel free to reach out. Thanks again, guys. Everybody have a good day.